Open any major academic journal today, and you will find a recurring diagnosis. Large language models do not understand what they are saying. To evaluate this critique, we have to look closely at its anatomy. The argument usually splits this diagnosis into two distinct parts: a highly specific technical condition on one side and an absolute categorical verdict on the other. The technical condition points to a precise deficit. A researcher might observe that the system lacks causal grounding in the real world, or operates without true communicative intent, or has no physical embodiment. But pointing out a technical flaw is not the same as proving a categorical verdict. Spanning that gap requires a sturdy bridge of logical justification. In epistemology, this bridge is called inferential entitlement. It is the required burden of proof, ensuring a conclusion does not outpace its evidence. Taking a narrow technical deficit and using it to universally deny understanding is an immense logical leap. The structural integrity of that exact leap determines whether current critiques of AI actually hold up. Let's set a strict boundary for what we are evaluating here. We are not attempting to prove that large language models possess understanding. Most debates focus entirely on proving what the machine can or cannot do. We are doing something different. We are stress testing the logical warrant of the researchers making the exclusionary claims. To do this, we apply a strict epistemological framework to evaluate whether these technical arguments possess the sheer strength needed to justify their absolute conclusions. This framework requires us to audit the critic's arguments, looking closely at whether they are demanding strict necessity or merely outlining sufficient conditions for comprehension. Withholding the label of understanding is an act of significant consequence. It strips the system of standing and shifts the trajectory of research, requiring the justification that matches that weight. Evaluating artificial intelligence means we must audit the logical rigor of the human evaluators just as relentlessly as we audit the machine's code. When we move from the technical architecture of an LLM to how the academic community judges its outputs, understanding ceases to be a casual descriptive word. It operates as a rigid criterion of admission. In research environments, this term acts as a gatekeeper. It dictates whether a system is granted epistemic standing. When a system passes this criterion and is granted the label of understanding, its outputs cross a critical threshold. They are treated as valid interpretations. The internal processes of that system gain prestige. They are suddenly deemed worthy of intensive study as legitimate candidate reasoning. But watch what happens when admission is denied because the system is missing a specified condition. The gate closes. A severe academic downgrade is instantly applied. The outputs are dismissed entirely as algorithmic artifacts or mere mechanisms of simulation. Because this single label strictly dictates the institutional and scientific standing of the system, the logical threshold for withholding it must be structurally flawless. Any exclusionary criterion acting with the power to deny epistemic standing has to answer to a strict logical framework. We can test the inferential entitlement of an AI critique using a four-question demand. Question 1. The critic must define exactly what specific capacity or standing their criterion admits. Question 2. They must state precisely on what evidentiary grounds that admission is granted. Question 3. The critic has to map the exact scope and breadth of the exclusionary verdict being issued. And question 4. They must define under what specific conditions their verdict would be revised or reversed. This framework is not a request for model transparency or access to open-source training data. It is a substantive, philosophical demand for justification. An argument is only logically valid if the strength of its answers to these four questions is commensurate with the scope of the capabilities it denies. To stress test the most common arguments against LLM understanding, we need to focus specifically on the scope requirement, question 3. This brings us to a critical term for evaluating complex cognitive traits, the cluster concept. A cluster concept is a capability made up of multiple overlapping non-essential traits rather than one single required feature. Understanding relies on a massive cluster. It involves linguistic syntax mastery, logical deduction, physical embodiment, and dozens of other interacting traits. Critics often rely on the limiting case of strict necessity. They argue that lacking one specific trait automatically negates the entire cluster. But logically, violently removing a single node, like physical grounding, from a massive cluster concept does not instantly destroy the structural integrity of the whole. To issue a categorical denial, critics face a strict burden of proof. They must demonstrate that removing the missing condition drops the remaining sum of traits below the threshold for attribution. Current exclusionary critiques fail the test of inferential entitlement because they assert strict necessity without proving that the remaining cluster of AI capabilities is insufficient to meet that threshold. This points to a secondary finding of the audit, a severe structural asymmetry in how the rules of assessment change depending on who or what is being evaluated. Institutions evaluate human understanding as a highly flexible, gradable, and domain-relative property. Human competence is defeasible. We routinely accept that humans can entirely fail to understand specific domains, like advanced mathematics or classical poetry, without revoking their general global capacity for understanding. Contrast this forgiving gradient approach with the rigid standard applied to large language models. We find a clear diagnostic anomaly. When assessing AI, the predicate of understanding spontaneously morphs from a gradable cluster into a rigid, binary threshold. The exclusionary criteria used to disqualify AI, like the demand for perfect causal grounding, are almost never turned back upon the human paradigm with the same strictness. The pervasive diagnosis of no AI understanding relies heavily on artificially elevating the human case, creating an unwinnable, asymmetrical assessment for the machine. A review of the historical record shows that relying on this flawed structural logic isn't a new phenomenon in AI critiques. It is a recurring pattern. Let's look back at our epistemic gateway and test its structural integrity. The immense, universal scope of the categorical verdict crushes the argument because the underlying inferential entitlement fails to prove a total threshold drop. These critiques present themselves as warranted criteria of admission, yet they structurally lack the inferential entitlement required for what they withhold. The technical deficits identified in language models are entirely real, but using a single deficit as a gate to deny all epistemic standing is a specious, unearned maneuver. We must reaffirm strict philosophical boundaries here. Humans and artificial systems likely still differ in philosophically important ways. Deconstructing these exclusionary arguments does not equate to a positive proof that language models do possess understanding. The reality is that the AI industry, cognitive science, and philosophy still lack a positive, unified theory of what mechanical understanding actually is. But until critics can supply the necessary inferential entitlement to back up their claims, the logical leap from a missing technical condition to an absolute denial of understanding remains structurally unearned.